Einstein, man, he famously said, "God does not play dice with the universe." But it's kind of crazy because recent experiments with quantum computers are making me think he might have been wrong. Back in 2023, these guys over at Google Quantum AI dropped a bomb in Nature Physics. They showed how quantum entanglement just flat out defies the way we think reality should work, and it completely challenges Einstein's whole view. They used Google's Sycamore quantum processor. That thing's a beast, led by Hartmut Neven and Dr. Eleanor Riefel, and they simulated a system of entangled qubits. The kicker is, you couldn't even dream of doing something like that on even the most powerful, regular computers. Their experiment basically showed that Einstein's idea of local realism just doesn't hold up. So yeah, let's dive into what this whole thing is about, because it's pretty mind-blowing. Okay, so Einstein was really hung up on this whole quantum entanglement thing. He called it spooky action at a distance. He thought there had to be some kind of hidden variables, stuff we just couldn't see, that explained how these particles seemed to communicate instantly across huge distances. But then this physicist, John Bell, came along in the 60s and said, "Hold up, let's test this." His results showed zero evidence of these hidden variables. These particles really were behaving randomly, and it just didn't fit with Einstein's picture of the universe. Now, flash forward to today, and quantum computers are cranking this debate up to 11. Using qubits, those are like quantum bits, scientists can now simulate and test this stuff with crazy accuracy. It's revealing even more about how weird quantum reality actually is. So get this. Recently, some researchers actually used quantum computers to simulate spacetime itself. They entangled qubits to create a model where not only do particles communicate instantly, but they also seem to influence the very fabric of spacetime. It makes you wonder if spacetime is this fixed thing like Einstein thought, or if it's actually more like a dynamic entity, constantly being shaped by quantum interactions. For example, scientists saw that entangled particles create these tiny ripples in spacetime. It's like a little hint that there's this deeper connection between quantum mechanics and gravity. That could be the first little step toward a quantum theory of gravity. This theory is one of the biggest mysteries in the modern physics, and it's cool to see some progress in this field. And here's where it gets really out there. In these quantum simulations, scientists are finding patterns that look like error-correcting codes. Like the kind they use in computer software to fix glitches. So physicist James Gates and others have started asking, could these codes be embedded in the fabric of reality? Some people are even wondering if our whole universe is like a giant quantum computer, with spacetime acting as a processing medium. I know, it sounds like something out of the Matrix, but it raises some pretty profound questions. Are the laws of physics just the software of the universe? And if so, who wrote the code? And what does it even mean? Okay, so beyond all the mind-bending theories, this stuff actually has real-world implications. Quantum encryption. The encryption methods that we use nowadays, like those that protect our banking information, could be broken by quantum computers. But quantum encryption, based on entanglement, promises unbreakable security. Unified physics. These discoveries could help us finally combine Einstein's general relativity with quantum mechanics, leading to a theory of everything. Consciousness and reality. Some scientists, like Roger Penrose, even think that quantum processes might play a role in human consciousness. Could our observations of the quantum world be shaping reality itself? The consequences are pretty vast, from revolutionizing technology to changing our understanding of existence. Einstein might have been wrong about quantum mechanics, but all of this wouldn't be possible without the questions that he asked. Quantum computers aren't just tools. Today, they are basically windows to the deepest mysteries of the universe.